Kia ora koutou. Thank you very much to the conference organisers for inviting me here. I'm going to give you an update on the latest climate change projections for Aotearoa, New Zealand. I understand there's a lot of council people in the audience and some academics and others who should or maybe have already heard about this. I hope you've already heard about this. We've certainly been trying to tell as many people as we possibly can that the latest climate projections are now available. This is work that we've done funded by MB and working with MFE. But if you haven't heard about them, then this will be your opportunity to learn a bit more about them and find out how you can get hold of it. So first of all, this web page is the NIWA web page where we describe the project that we undertook to update all of the climate projections. So I guess these presentations have been made available to all participants. I'm just guessing. I'm happy for this one to be done that way. So you can either write that down or just Google NIWA climate projections and you'll find that webpage. It describes the whole process that we went through. And then there's another webpage that we've got, which is a little bit of blatant advertising, you know, what NIWA can do for you to interpret and understand and utilise these projections. So that's it for advertising. So I want to give you a little bit of a rundown, actually, how we've done these projections or this downscaling process this time around, because it's been a bit different than previous times. This map actually shows you the spatial resolution of the regional climate model that we used to do the downscaling. So the white areas there are a spatial resolution of 12 kilometres. Which is the sort of the base resolution for doing the downscaling modelling, and then we further downscale to 5 kilometres. So the ultimate spatial resolution of these data across all of Aotearoa, New Zealand is at 5 kilometre grid resolution. But the regional modelling that we do to take the global climate models and scale them to New Zealand is based on this type of grid. 12K over New Zealand, but the really cool thing about this, and we think is a really innovative approach that we've used this time, is this is a stretched grid. So it's actually stretched from tightened around New Zealand as much as we possibly can, but then the resolution, as you see, as we go out from New Zealand, is stretched, so it increases slightly, gradually as you go out. Now that means that you don't have any hard boundaries around the edge of a local regional model, which is what we had last time, and that caused some difficulties when you have a global model, which is at a very coarse resolution, and then suddenly goes into a nested high resolution regional model. There's always these weird boundary conditions that you have to overcome. So a stretched grid is a really cool way of overcoming that. The other thing it does is it gives us much more information about whether that's coming from the north or from the south or to impact New Zealand in particular. We're really excited that this type of model now gives us a lot more insight about things like ex-tropical cyclones making their way to New Zealand and what that might mean for the future. So it's opened up a brand new sort of capability in our climate science that we can now do in New Zealand just by using this type of grid configuration, which is very cool. This is basically what you get if you have a global climate model and you try to understand what climate projections look like for New Zealand. We absolutely need a better resolution than that. There's just no way you can get any insights about what's happening in Palmerston North from that type of model at that type of resolution. So that's why MB have invested in NIWA to do the downscaling, and MFE have worked with us to do that, because what we're doing is we're taking that and we're getting to that. So now this looks very much like a weather model that you would see, you know, giving a weather forecast for New Zealand, and we know that that then takes into account all things like, you know, local topography and distance from the sea, etc. So now you're starting to get into that resolution where you can, and as you see in those boxes, even resolve tropical cyclones in the model as they track down towards New Zealand. So a big advance from where we were before from the new modelling approach, and a massive advance from just using global model. So a call out there to anybody that's doing climate change work and you've got access to global models, because you can download that, of course, all the global model data. Just be careful if you're using that type of information to derive an understanding of what the future climate will be for a particular location in New Zealand. You will get something that's probably not realistic. Most important to do some sort of downscaling. What we did is that it takes a lot of compute effort to do this downscaling. On the left there, you'll see that all of those are 52 global climate models that we could have downscaled. So these models are run at institutions like NIWA in the US, or in the UK at the UK Met Office, for example, in Europe, for example, in Asia. We don't run any global models in New Zealand, but we can take the global models, or a selection of them, and we did this case, select across that range. We went, some ECS is equilibrium climate sensitivity, which basically means how much global warming would you expect if you doubled carbon dioxide in the atmosphere. And you can see that different models have different climate sensitivities. And this is the nature of global climate modelling, is that they are subtly different, and they will give you different answers. So it's important to look at more than one model as well. There's this lesson number 2. So we selected 6 of these across the different range, and we downscaled those. And we also looked at 3 emission scenarios, or SSPs, they're called, shared socioeconomic pathways. These are the 3 kind of middle SSPs from a range of 5 that are used by IPCC. Subsequent to that, we've had requests from, actually many councils have led the call to MFE to also downscale the most extreme high SSP, which is SSP 585, which is very, you will be familiar with the RCP 8.5, which was the one that, the scenario from previous times. Actually, the SSP 370 is about equivalent to the old RCP 8.5, so we already thought we were doing a pretty high emission scenario anyway. But a call had come from users to also downscale the very high scenario, which we're doing, and it'll be ready in about a month's time, actually. So maybe lesson 3, now I'm going through these, aren't I? Lesson 3, be wary of that very high emission scenario, because it is now very high. They'll be predicting temperature changes of 4 and 5 degrees by the end of the century. That's pretty darn extreme. I'm going to sort of skip through a bit of this. This is a talk I gave for another purpose, but basically we've tested to see what the extra value is of doing the downscaling. Anything in this kind of matrix of different climate indices on the vertical axis, and then across the different models on the horizontal axis. Anything in the red means an increase in the value of doing the downscaling versus just using the global model. So you can just see, because there's so much red in that diagram, that it is absolutely critical that you do downscaling in order to get that increased value across different climate indices and extremes in particular. And this is the other cool thing I want to show you. So down on the bottom there is, the bottom image is actually from, it's a database of tropical cyclones that have occurred over the last 40 or so years. SPEAR-TC is the name of the database. So it's the genesis area, which is the yellow dot, and then the tracks. And so that gives you a kind of a picture of the tropical cyclone climatology in the Southwest Pacific and tropical Pacific. And you can see some of those tracks obviously come near us. They don't retain their tropical cyclone strength by the time they get here. They become ex-tropical cyclones, but as we know from Gabrielle, that's still rather nasty by the time it gets here. If you use a global model on that top left, this is one of the models that we downscaled just at that global model resolution. You get that type of number of cyclones formed in that same sort of historic period and the tracks. And so, it's getting there, but it's obviously not getting the numbers right. And then if you do the downscaling to the CCAM model, which we use, you can see now that you're much more likely to represent these tropical cyclones in that modelling. So we're much more confident now that we can understand more about these things coming out of the tropics and impacting New Zealand than we ever were before. So have they changed much? And I guess this also is a little bit about what, if you guys are grabbing the data, you might want to compare the new projections with the old projections. I did this talk actually for the Kiwi Fruit Breeders Association in Bay of Plenty. And so I just put an example up of what was there before. So we've done a lot of these climate change reports for different regional councils around the country. We're actually going through a process of If a council wants to update it, then we'll help them with it. We're doing the Auckland and Greater Wellington at the moment. But you basically, I think, if you're setting your policies and your guidelines and your operating procedures on previously produced information and previously produced reports, it is a good idea to update them. It's not wrong to continue to use the old projections, but they're now over a decade old. So there has been a lot of advance, not just in the way that we do the downscaling, but actually in the global models themselves. This was just a couple of, there was a paper on kiwi fruit production that I did way back in like over 10 or 15 years ago. You get this type of thing. So now, we've got the old projections from what we call CMIP 5, that's the previous projections that we downscale for New Zealand, and the new projections. So you can generally see, and this is a case pretty much across all of New Zealand, that the new projections are hotter. That's mid-century and end-century, just a comparison from for the RCP 4.5 and the new SSP 245, which are very similar type of low to mid-range emission scenarios. So yes, we're actually the new predictions for the same future periods are now hotter than they were before, generally across all of New Zealand. And that means that things like the number of hot days are also up from what they were before. So just talking to Alex before about what that might mean in terms of impact on grass and etc. And vegetation and also things like animal health is really important to understand. You can see these changes are actually quite significant by the end of the century. So that's the same future period, just the old versus the new, really indicative of the need to update this information. Things like the total rainfall, depending on where you are in New Zealand, there are subtle changes. In this area here, the Bay of Plenty, there was definitely a change from being actually a sort of wet to dry, north to south projection to now mostly drier. So these have changed and will impact you. So just, I'm going to flick through these really quickly. These types of information that you can now get is like the daily mean air temperature, number of frost days, for example, and these are projections for end of century and mid-century. This is growing degree days, or the amount of heat that's required to sort of spur on growth of things like subtropical species, or even you can do it based on a lower temperature threshold for pasture species. Total rainfall is also a new data set. And different seasons, of course, so that's the summer rainfall versus the annual. PET is a potential evapotranspiration is an indicator of droughtiness. So how much you accumulate PET gives you an indication of how long you're spent in drought. So that's another variable that we've got. Okay, so quick, where can you get this, right? So first of all, that's our webpage again. That'll give you all indication of how you can get hold of the data. As I said, Google search NIWA. But what does it look like? So on that, or how you can get it. So on that webpage is links, first of all, to MFE's web pages and MFE's new tool for visualizing the data. So you can download the data for free from that MFE site. This is the MFE site, and it's pretty self-explanatory about accessing the data. Download data button up there at the top right-hand corner. And this is MFE's new map viewer, which is pretty cool. I don't know if many of you have seen it already and have played around with it. But basically, it's a way of visualizing this data on a online GIS system. So you can choose different baseline periods, different SSPs, different future periods and different seasons on right, and then you can choose different variables on the left, and it will upload the data for you, and you can zoom in and pan around, etc., all those sort of functions that you have with an online GIS. You can't download the data from here, but you download the data from the other MFE site. So you could sort of use this as a visualization tool to understand a little bit more about what the projections are showing for your area, and download the GIS files. upload them into your own GIS systems, and then play with them to your heart's content. I guess I put this up there because I just wanted to also give you the sense that we're doing a lot of work, trying to put a lot of attention into ensuring that there's good, robust, published information, not just the first ones, which are the kind of reports, if you like, or the guidance, if you like, that is good for having as a resource in for your own decision making. But there's a lot of science now that's from this work getting published in peer-reviewed journals. So we're trying to give you that robust science backbone on which that you can make good decisions. Kia ora.